All right. Sharing my screen. All right, more cleaning. We're gonna try a new data set. Start out tidyverse, janitor, set up. Okay. So here, load my packages. Load my data sets. Now I'm saying sets because this one looks like it's in two parts. And so it's in our course data directory that you've got Utah County Precip. And I've obviously looked at this before back in November 2023, which was, I don't know, I've slept a few times since then. I have no memory of this whatsoever, even though I wrote some code. This is hourly precipitation data. In Provo, we've got station name, elevation, latitude, longitude, date, and hourly precipitation. Hours with no precipitation are not shown. Oh, that's great. Absolutely beautiful. Instead of having an NA or just a blank spot, they're just going to leave that out. What a turd. Okay, and then the value 99999 means missing. Isn't that beautiful? This is fairly common with government data. Sometimes it's negative 999999. Sometimes it's 9999, whatever. I don't know why. There's some historic, terrible reason, no doubt, but just be ready for that. If you see that, if you're dealing with government data, that's pretty common. Maybe, I'm not going to speculate. It's stupid. Hour 0 be listed as first hour of each date. It actually occurred on the previous day, since every hour is the accumulation of the previous 60 minutes. That's fair. Okay. Year, month, day. At least they're explaining everything for us. This is nice. Okay, Western is less than 0. Yep. I'm gonna leave this around. We might need that. Stick it over on this other. Okay. So we've got two files, 1980 to 2014, and then 2014 to 2021. So dat1, read CSV, data, Utah County Precip, 1980 to 2014.csv, that's dat1, and let's take a look. Okay. Station name, date, hourly precipitation. That is, oh, this is beautiful. Given in hundredths of inches or tenths of millimeters, depending on the user specification of standard or metric units. I have no idea. It's got to be hundredths of inches, because 0.005 tenths of millimeters is less than a tiny piece of a raindrop. Okay. So this is inches. Yeah, 400ths of an inch. All right, we're going to want to get that to metric. We're going to want to clean this date up. Oh, it's already in POSIX CT format. How beautiful. So that's already there. We've got hourly, station name. Maybe this doesn't need any cleaning. We'll do .2 hourly Precip 2014 to 2021. Let's see. Lovely. 124 variables. Oof. Okay. Well, this is where we earn our keep. We got date, report type, .3, source. None of this was in there. Backup equipment, backup direction. And it's all missing anyway. And we just want hourly precipitation. And that's all missing. Seriously? Okay. .2 hourly precipitation. Oh, of course. So we got a bunch of missing stuff. Understandable. Then we've got these values, and then we've got the letter T. I do not see that over here in this data explanatory file. Scrolling down, T indicates a trace amount. So that's 0. So since 1996, T can appear. So we're going to change T's to 0. I'm going to start making a list here. Change T to 0, trace amount. Get only variables from .2 match .1. Make the column names match. Merge with a full join. I'm sure there's going to be more, but that's where I'm going to start. Okay, hourly precipitation. Names of .1, station, station name, date, HPCP. Let me just move this over here. Okay. I'm going to clean the names as I read these in. And their hourly precipitation. Okay. .1, HPCP, unique. Those are numbers. We don't have any trace values in there. Okay. So I'm going to start with .2. I want basically station, station name, date, and HPCP from .2. But what I've got is a whole bunch of stuff. And this is normal. I mean, in 1980, they had fewer measurement devices at this station, no doubt. Let's make sure that we are dealing with the same station. Go up 427064. Yep. Station. Is this a different station? Did they rename it? Monthly, hourly, daily. These are both Provo. And that station 27064. I vaguely remember downloading this. I pulled it off of the NOAA weather website. They probably renamed the station in 2014, and that's why, and added new instruments, and that's why we've got new stuff. Also doing short duration precipitation. So they've added a bunch more stuff that they're measuring at this station. I'm guessing that that's the same. Okay. Just Googling here. Making sure these are the same. They are not the same. Okay. So that Provo one stopped operating, and we've got this new station in South Jordan. Good to know. All right, so those stations really are different. That one, station name, yeah, Provo, Utah, so it's BYU. All right, so we really are switching over. It's nearby, but a different station. And so we don't need to change those. But we do need to have the same names. So we need station. We've got that. Station in both. I'll add a station name. So dat to station name is South Jordan. So we're going to add station name to 2014 to 2021 data set. And then we want the hourly precipitation. Okay. And that was .1 HPCP. So I'm just gonna do it this way with base R. HPCP equals .2 hourly precipitation. So I'm just copying it over. Okay. Now I'm going to clean that up. All right, so that is character class, if I'm not mistaken. Yep, we want to turn that into numbers. So I'm going to say dat2 HPCP where dat2 HPCP is equal to a T and I'm going to turn that into a 0. Okay, And then I'm going to say that is that type 2 as numeric. Okay, so we've got station, station name, HPCP, and then we need date. Dat2 date. How does that look? POSIX CT, that's beautiful. Okay, so already cleaned. And so now I'm going to take Dat2 and I'm going to select those station, station name, date, HPCP. We got a double, that should be a character. Mutate station equals station as character. And then select those names. We've got South Jordan. And then I'm going to full join with Dat1. And we'll just call this Dat. Okay. A lot of missing values in the 2014 data. But not entirely. Okay. So I'll take Dat, pipe it to ggplot, just a sanity check here. X equals date, Y equals HPCP plus geom point. And let's color by station name. Sanity check shows that we failed here. Okay, so South Jordan picks up at 2014, but the Provo station, we've got lots of close to zeros and lots of thousands. So we've got a problem. And I think it's going to be that weirdness in the documentation. Not the data measurement flag. I think it's going to be a mixture of hundredths of inches and tenths of millimeters. That's awful. All right, take you over there. So let's see. Clean measurement units in Dat1. We've got a summary. Oh, 999 means data missing. That's right. That's what's happening. Right? Okay. So Dat1 HPCP, where Dat1 HPCP is equal to 99999. .99. There they are. Turn all of those into NAs. That's more like it. Okay. And let's check the scale here. Dat $HPCP summary. Max is 1.25. Right there. Min is 0. Okay, they all seem to be on the same scale. Precipitation. Excellent. What I'm going to do is take color equals station name, add that as an aesthetic only in the geom point layer. Oops. And then add a geom smooth. Force it to use a generalized linear model or just a regular linear model. So we're going to get a geom smooth that doesn't have a color aesthetic, but the geom point does. So we can look at the whole thing over time. And there we've got ourselves a nice little trend. I don't know if that's significant, but just quickly, I'm going to preview some modeling here. So I'm going to do a generalized linear model. Data equals dat. My formula will be HPCP as a function of date. We'll save that as model. And then a summary of that model shows us that date is significant. And it's a small estimate, so a small downward trend, but it is negative. That slope is significant. We're getting less precipitation in 2021 than we did in 1980. Probably not a big shocker, anyone who lives in Utah. Okay, well, that wasn't too bad to clean. Saw some weird stuff with the 999, and I don't know why they were coming out as 999.99, but the data dictionary lied to us. Also not uncommon. Okay. Looks good. We could clean this up a bit more and do a daily precipitation. Do we want to do that? Sure, why not? So dat, basically we're going to need to get away from the date with hours and basically just pull in the date. So let's see. I am going to load LubriDate to smooth out the working with dates. Okay. Year equals the year of date, right? Because LubriDate gives us year, month. Month equals month from LubriDate of the date, right? So we're getting year, month. Day equals day of date. Beautiful. And then I'm going to mutate I'll just call it date 2. This will be a simplified, removing all the timestamps and just looking at the date equals. So I'm going to paste together year, month, day, and the separator that I use will be a dash. And then I'm going to say as POSIX CT. There they are. Okay, so we've gotten rid of all the hours. That makes date 2. Then I can group by date 2. and then summarize total precip, or I'll say daily precip equals the sum of HPCP for that date, and I remove true. Okay, so for each date, we've got daily precipitation, excellent, and let's see. And maybe plot that. Pipe that right into here. Date 2. We're losing station name. That's okay. Well, no, it's not. I'll group by date 2 and station name. That way we can still color by it. All right, so there it is in daily format, not hourly. And oh dear. Let's model that as well. I'll pipe that right to GLM. Data equals, and here's a weird one, dot. GLM wants formula first, and then family second, and then data third. The order matters because if we're using tidyverse style stuff, we're piping one thing to the next. The first argument in every tidyverse function is going to be a data frame. Here, the first argument is formula. So we basically need to say like, oh, and by the way, the data is dot. The thing that we just passed to you. That's what the dot means. So data is that. And then the formula equals daily precip as a function of date 2, which is what we called that. And then I'll pipe that right to summary. So a more significant downward trend, or a stronger downward trend, sure looks like it here compared to our last plot. Yep. So we're looking at daily averages or daily totals. This is weird right here. I don't know what to think of that. They changed the way they measured things. That's obviously what's happened. Beautiful, but it's still on par. They just kind of grouped them. So yeah, downward trend over time. It's a bit stronger when we look at it daily rather than hourly. Still highly significant according to this general linear model. All right. The end.